Hi, everyone. So, unfortunately, it's not going to be as interactive as I was kind of hoping for. I mean, it's not like I'm used to talking in public, used to seeing a show of hands, seeing everybody's smiling faces, nods of confusion, of agreement, and looks of confusion. So, we're going to do our best here. This is my first time, like I say, giving an online conference, an online workshop. And, the goal here was to introduce you folks to C#. In the context of AEC visualization. So at Vim, we've developed a technology for viewing and working with extremely large architectural models, and that technology makes it. We've developed a plugin architecture for our desktop application, and plugins are a great way to get your feet wet in the world of programming, and particularly in C#, because it kind of limits the scope of what you can do. When you're starting off learning to program, I know it can be quite overwhelming. You end up with a lot of options. Do I want to create a .NET Core project? Do I want to create a .NET framework? Do I want to use .NET Standard? Am I creating an executable class library? All of these options are available to us today, and it becomes quite overwhelming. And by working through a kind of a tutorial on how to create a plugin, it can be a very effective way for us to get our feet wet and to learn and to see what's possible. My assumption is that many of us here today are actually more from what we call a scripting background and are familiar with languages like JavaScript and Python. And I would have at this point asked for a show of hands, but I remember Damon explaining to me, yeah, he's quite familiar with JavaScript and these kinds of environments. So I wanted to start off just by explaining what the difference is. Before I go into that, let me just tell you kind of the way we're going to structure this talk. I'm going to talk a little bit about C#, and you're going to get to see my pretty face, and I'm going to talk a little bit about C# and why it's important, and why it's important specifically in the AEC space and the types of applications that are using it. Then I'm going to show you how to do a very simple Hello World program in C#. Then I'm going to show you the Vim technology briefly, and then we're going to do a Vim plugin. All of the documentation that I show you today will be posted online, and throughout the coming week, I'll be adding more and more samples as we go in order to help people who are learning about the Vim platform and learning about C#, and so that you can have a chance to kind of get ramped up nice and ready for your the hackathon when it's kicked off officially at the end of the week. All right, so talking about C#, a lot of people ask, well, it's a compiled language, is it, or is it a scripting language? So, languages actually don't fall into one of those two categories. It's the tooling that does. You could take a Python program, and even though it's considered a scripting language, you can make an executable out of it. Same with JavaScript. But typically with scripting languages, what you distribute to people is the source code itself, the code that you use to write your program in. So in JavaScript, you take the code that I wrote my JavaScript in, and I give it to the browser on somebody's computer, and that browser executes it automatically. Behind the scenes, what the computer does is it converts that source code into something that's executed. Similar for Python. The requirement with Python is that on a target's person's computer that they're going to have an executable Python that can actually read and understand the code. With a language like C#, you need something called a runtime, like what we call, like, for example, .NET Core, .NET Framework, and these are runtimes. And what they do is they interpret the compiled C# program and execute it. And they convert that, when I say they convert it into a machine code that can be understood. This differs from the languages like C++, which are called native languages, or languages that compile into a native form, which is understood natively by the machine itself. And those have to go through a more specialized process, and it has to be done for each different platform you're targeting. Whereas, so you have these different degrees of portability that kind of arise. If you're doing C++, you have to create specific executables for the different platforms. If I'm creating a .NET program, specifically if it's, particularly if it's let's say a .NET Core, very general .NET language, I can target multiple platforms. I could run it on an iOS or on an Android with the right runtime installed. All right, so that's it. The reason why I think C# is so interesting is it allows you to build not only programs that can run on multiple platforms, but it allows you to build scalable applications. which means that basically your applications, it's very easy for you to add new features to it and build and build and build to the point that the code continues to be maintainable and your programs are able to be extended by other programmers. You can build your team up. Whereas you'll notice with languages, I don't want to be, derogatory towards Python, but if you see a Python program and you evolve it and you evolve it and evolve it, it tends to start to become harder and harder to maintain as it grows. Where a language like C# has more structure and it's easier to refactor and to make changes as you go. The other thing I wanted to talk about is the fact that in the AEC space, there's a lot of applications out there with C# APIs. So an API stands for Application Programming Interface, and that just basically means that that's the interface between that core application and plugins and tools that you write in your language. So when I talk about that, another term for it is also called an SDK, stands for Software Development Kit. A software development kit is broader than an API. The API is just the interface, just the function calls I can make, where the software development kit is all of the supporting tools and the documentation and the samples. So software development kit is broad, API is a smaller subset of that. And you can have multiple APIs for a single software development kit. So some of the examples, of course, are Revit, Dynamo, Grasshopper, 3ds Max, which is an important tool for the AEC space when you want to do visualization. Of course, Unity's got one. The list kind of goes on and on and on. I'd even mention Maya as a good visualization tool with a C# API. The other advantage of C# is that it's got really good interoperability with other languages. It's very easy to extend C# with new libraries written in C++. And there's a couple different ways to do that. One way is a language called C++ over CLI. There's a few other ways of doing it by calling directly into C++ DLLs. So you can extend a C# application with custom C++ libraries that exist already. So that allows you to kind of reuse things that exist elsewhere. And the other advantage is that you can also use it as a scripting language in a way. You can actually write C# scripts and execute them from within C# itself. And that's kind of the way that Unity does it. Allows you, it does we call compile on the fly or just-in-time compilation. So C# is a very, very interesting language, but the challenge with C# is perhaps the fact that there's a bit of a learning curve at the very beginning, because you have to figure out how to set up your environment, you have to figure out what references are, you have to figure out what assemblies are. So there's a bit of a jargon, and there's a set of technology, terminology around it that can be a bit daunting. So the goal of today really is to help eliminate a lot of that for you and to say, oh, I can now get right into the nuts and bolts of writing code. And I think for everyone here is once we have code, we realize it's actually quite straightforward. It's quite easy. Code is simply, it's writing your formulas, it's writing your event handlers, it's reading files, communicating with other APIs. But really what the Pons S sonoris is really overcoming that initial hurdle of setting up an environment and making it work for you. So the thing is once you know that something's possible, it becomes a lot easier, and you start to realize, oh, this is not actually as complicated as I thought it was. So we're going to work through that today. So as I said, I kind of wanted to show you the C# environment. We're not going to spend too much time doing that, but I'm going to share my screen, and we're going to set up a project together. Oh, no, Steve, I don't have the capability to share my screen.
Wow. How in the world are we supposed to do that? Hold on 1 minute here. Let me... You should be able, I don't see any restrictions. Who can share? Can you try, how about now?
Yep.
And I'm not seeing the screen share yet. I don't know if you have shared it.
It says I am screen sharing now. You see it?
Yeah.
Okay, perfect. So
Great.
I'm going to launch my Visual Studio. So let's see some interesting stuff. Open a project or solution. Oops, we're going to create a new project. So we have a lot of templates to choose from. Let me just quickly run through a couple of what this means. We have different platforms today in .NET. The classic is called .NET Framework. And generally speaking, when you're doing Windows development, that works just fine. In fact, it's probably the easiest, partly because there's so much old documentation about it. .NET Core is a more general cross-platform framework. Same with .NET Standard. Use .NET Standard actually to create class libraries that can be shared between .NET Framework applications and .NET Core applications. If I'm creating an application, I'm either targeting .NET Framework, which is Windows only, or I'm targeting .NET Core, which is cross-platform. For the time being, and to keep things simple in your initial projects, and also too, because the majority of AEC software does run on Windows, just go to .NET Framework. And the only thing you also need to remember is, well, which version of .NET Framework do I want? So what I'm going to do is I'm going to create a console application, and it gives me all these options. This is, oh, do I want a workflow console application? I don't even know what that is today. We've got .NET Core and .NET Framework, so we're going to just go with .NET Framework. If you ever create a .NET Core application, you may say, oh, that sounds like great. That sounds great. I want to do that. It's fun, but it introduces certain extra challenges because it doesn't run natively. It needs a special extra runtime in order to run those applications. Whereas Windows is just kind of like, oh, I recognize .NET Framework. I'm just going to go with it. So I'm going to make my own new app. So it's, my first app. It's got the location. We'll just leave in the default location for me. And I'm choosing .NET Framework 4.7.2. It's relatively stable, not much has changed, so this is a very good choice. .NET 4.7.2, lots of features in it, very robust. So now we're going to go create, and this is going to be a true Hello World program, meaning there's almost nothing to it. In a console application, you have what's called the entry point. And all executables kind of have this. This is like, well, where does the code start? Well, it starts in this function called main, which is, old standover from the old C++ days and C days. So you have a function called main. And main is basically where your program is going to start and start executing. And args is basically what's passed on as command line arguments to it. And we can just ignore that for now. So console.writeLine. So I'm using autocomplete a whole lot. And autocomplete is one of those features that today, as modern programmers, we almost can't live without it. If you take away my autocomplete, all of a sudden I'm just completely useless, despite the fact I've been programming in C# for like, I think 18 years. I think it's hard to keep track. No, 15. So anyway, let's write hello world. And now this, you can imagine what this program is going to do. These are all grayed out because I'm not using these namespaces. So libraries, they are divided up into namespaces in order so you to kind of organize your code and to group it. I don't need those. The only one I'm using is the system namespace. I don't have to delete those, but I did. And I'm going here. So now the question is, how do I build and run? So you can do it in 2 steps. You can build, and then afterwards I could go debug and I could run my, just say start my instance. So if I say start new instance in the debugger, it'll actually run my program with what we call the debugger attached, so that if there's any errors that happen, they'll show up in my environment. And I'll show you an example of that because learning how to debug is kind of key. All right, so it ran and nothing happened. Well, let's do this console.read key. What happens is it ran, it executed, and it went away. So let's just do it this way. Hello world. It printed. We have my little diagnostics window. It's telling me about what's going on. I press OK, and it's over. Oops. That's hello world in C#. It's simple as that, and we can do whatever I want. And let's cause the world to blow up. I'm going to do a calculation. Var x equals 42 divided by 0. Hello world. It's detected that I'm dividing by a constant, so we have to trick the program var y equals 0. Here, now it doesn't know anymore. It was telling me in advance that there was going to be an error during execution. And that's one of the big differences between C# and languages like Python and JavaScript, is that C# is very good at predicting when an error is going to occur and finding it for you. And that's where you can see the red squiggles. And that's one of the reasons why my default go-to language today is C#, because I'd rather find the errors before I execute my program, because finding them during execution is so much longer. So let's find this error, and I've created this one on purpose so that we can see what the debugger looks like. And this, as you see here, we have a system divide by 0 exception. So I've run within the, we don't call this just an editor, we call it an integrated development environment, because it's multiple tools that traditionally used to live separately are all integrated into one. So it's the integrated development environment. So the debugger has stopped us automatically because it detected an unhandled exception, and that exception is the attempt to divide by 0. So this is great. Now we see what happens when the debugger detects an error at runtime, and you can go ahead and fix it. So we stop and we go on. This is really, like, for many of you who've already used C#, this is obvious stuff, but when you're first starting off, learning what these things are and seeing them actually happen, it's really empowering, so you understand how to actually work through all of this stuff, and this will move you along a lot faster. So we've seen basically, okay, this is the C# environment. I can write a program. I mean, I assume everyone here is familiar with programming, but it's pretty simple. It's like a calculator. If you're not, it's a calculator. You can do math. You can read and write to the file system. You can read from your keyboard, and you can draw to the screen, and then you can connect to the internet. And apart from that, that's basically what computing is. There's a lot of complexity all around making all of that happen and making all of it easy and scalable. And that's really a lot of the complexities introduced by us as humans. The art of programming is really about the art of managing complexity and trying to figure out how to express concepts that the computer can execute, but in a way that humans can manage and get your heads around. So, if something's confusing and overwhelming, that's our own fault, and we have to figure out how to make it simple. All right, off of the soapbox, let's take a look at what Vim is. And I wanted to show you our fun little tool for viewing. Okay, so I'm going to open up our the big project, which is our Vim desktop application. So you don't actually have to do this on your side, but I'm doing it on mine because I had a problem with the installer. On a development machine, when you're trying to install something, you're going to end up with a clash sometimes, because my version as a developer of the Vim technology will conflict with the installer. So I'm going to have to run it from within. For you, you won't have that problem. You're just going to be looking at a simple plugin. This here is my test windows. I'm going to shut this down. All right, here we are. We're in debug mode on any CPU. All right, then I'm going to run. Okay, I'm going to show you something that's in this view here on the right. I want to explain to everybody what's going on. What you're looking at is called a solution. And a solution is a collection of projects. Projects can be, like libraries, or they can be executables, and it could be a number of different things, really. It could be even in different languages. And some of this is actually written in C++, some in C++ or CLI. This is all of our source code. It's all here. Interestingly enough, a lot of it actually is open source. And I'll be sharing those links over the course of the week, so you guys can actually look at some of our open source libraries, like our, our math libraries and our geometry processing libraries and whatnot. All right, so let's run the program. I'm pressing F5, which is the equivalent of pressing the start button, which is equivalent to pressing start debugging here. So let's go start debugging, F5. And how does he know what to debug? Well, he starts at the project called hello world.plugin. Now, let me show you hello world.plugin while he's loading. He's a plugin I wrote for the Vim desktop application. And if we go into his properties, He's not letting me right now because we're debugging. Give him a second. I do not need my diagnostic tools. We'll shut those down. Go to properties. These are the properties of my plugin. We have the application, top level properties, which framework it's targeting, what is the type of output it is. You can't change these while the program's executing, but he's just starting up, warming up. Slower again on my development environment than on yours when you run the desktop application that I sent the link for. You have a debug mode, and in the debug mode, you can actually say, I'm a plugin, but I'm actually hosted within the context of another program that's executing. Because a debugger needs to know, well, where's the host application? But if I write a plugin, he goes, well, there is no host application. There is just me. So you actually have to tell the environment, the debugger, where is that executing process? And that's what this is. This says my executing process is this program, vim.exe. So when I press F5, it launches that program. The debugger knows to find it. This is my, sorry, I have to move you folks over here. This is my application. Let's open up one of the examples. I'm going to start off opening, well, I'm going to dive right into it. Time is of the essence here. I'm going to open up an application, the Stadium. The Stadium is one of the sample files we've posted on our repo. While he's loading, let me quickly show you something. I should launch up my, sorry, give me a second. I'm going to get my Chrome so you can actually see the repo. Again, it's one of those things, if you see it, it makes it real. Vim, sorry, github.com, vim desktop SDK. So this is a public SDK that we're putting online. Ignore the fact that I haven't paid my bills. We've got some documentation here for you to follow along with. The details, the high-level details of how to create a Vim plugin, and we've got all the libraries that make up a Vim. And this is what I'll be covering today. We've also got our sample files. So if we go to releases, you have two releases. We have our sample files, and this is the Stadium that I downloaded. You also have we call the Wolford Residence from our CEO, Errol Wolford. It's a model of one of his homes. And we also have the SDK release, which is actually this is actually the viewer, the desktop application. All right. So while I've been talking, I've been loading the thing in the Stadium within the application. And I apologize for the slowness because of the fact that I've attached my debugger. So when you attach the debugger, it's a lot slower than when you're executing on its own. And I don't think Zoom is helping us much right now. So while it continues to load, I am going to show you where the application goes. So we are going to go take a look at the application so you know where it exists. In here, I go into Vim. Once you've installed, you'll be able to find it here. This is where the shortcut menu is. Go right-click on it. Go to Open File Location. And this is where we call the desktop applications installed. And you'll be able to launch it directly from here. Now, these are all of the core libraries that the application itself ships with. Some of these constitute the we call the API, the interface that which your plugin will talk to. And these are all C# libraries. Anything starting with Vim dot is a class library that your application can communicate with, except for these two. Well, technically, you could even leave that in. These two are not yet ready for prime time, so I would advise leaving them out, but it doesn't matter if they're there. But these are the libraries that you'll be linking to when you're building your executable. When you build your plugin, the plugin itself has to be put into this location. And I'm going to show you the location where it is. Use a profile, vim/desktop plugins. And this is where my Hello World plugin lives. Notice that it has to end with the extension .plugin.dll. When the desktop application starts up, it scans this particular folder. It's not necessarily Christopher Diggins. This actually can be, again, %user profile. It scans this folder specifically for any DLLs with the name .plugin.dll, and then it looks within those DLLs for classes that implement a specific interface. And I'll show you that in a bit. So without further ado, here's our stadium that's loaded up. Remember, the loading time is very, very slow because of my debugger being attached to it. And also because I'm streaming through Zoom. But I'm navigating through this space using WASD. These are famous controls for controlling shooter games, like we call the first player shooters. And so as I navigate around, here we are within the stadium. Let me slow it down. What you may notice actually is that this little widget here is updating while I move around. So you'll notice that the camera position actually is changing. And I can actually change the camera to look up, look down, left. Could even rotate around and get really cursor if I wanted. So as I'm navigating around, this is our desktop applications, one of the tools we release as Vim. I can actually click on any object and see information, the BIM data from that object. And this is actually exposed to us through the API as well, and it'll be something that I'll be providing documentation for throughout the week. But the first sample plugin that I want to walk you through is actually this one here. So as we but well, I'm just going to move around a bit more. So as you see, this is a really, really big model that we exported as a single Vim from Revit. We use a Revit project that was multiple linked files and quite large. And what we do is we're able to generate a single Vim file which encapsulate all of the geometry data, all of the instancing data, and all of the BIM data, and then load it load the geometry data into the GPU, and then load the BIM data into the CPU for querying at runtime. All right, so this is a space that I could spend a lot of time walking around. As you notice, it's very, very quick and responsive. Now, our application is built in 2 languages. There's, well, actually more, technically 4. So let's go through them. You've got C# for the user interface and a lot of the business logic, the opening of the files, the controlling of the main application. You've got a C++ layer that communicates with the GPU, and he funnels data from the CPU up into the GPU and prepares all of the data buffers in order to do the rendering. We have code written in shader language for the GPU itself, and so that a lot of that high performance rendering happens in the GPU itself. And of course, we got a little bridge in C++ over CLI. Our plugin architecture is all written in C#, and it allows you to funnel data back and forth between the different layers. But we just provide a convenient C# wrapper around it. But it's very efficient. I mean, what I wanted to show you is that we actually are responding to all of the frame updates in order to update this little C# widget. One of the things that I wanted to mention about C# and one of the reasons why it becomes quite interesting to people is it's got a very it's got a couple of different and very powerful user interface libraries for it. The old legacy library is still one of my favorites. It's called WinForms, and it looks like basically, it's these types of user interfaces. Modern, more customizable interfaces can be done using a GUI abstraction layer called WPF. Our application here is showing the mix and match of the two. For the plugin, I used WinForms because it's a lot easier to get up and going. But when you want really custom look and feel and a really good styling, you're going to find that you're going to want to go to WPF. And in fact, there's tools to allow designers to work using styling tools and design tools with the developers. So on our team, we've got designers who can do some coding, but they can focus purely on the design and let the developers worry more about the logic, and it allows that separation. And that's what WPF is really good for, and that's one of the strengths of C#, is allowing teams of people to work together. All right, I'm going to shut this down, and I'm going to show you, oh, actually, you know what would be very interesting, I think, for this group, is actually to see the debugger hit this right now. Now, you could do this to an application today using any debugger. I've already launched the debugger and it's already attached to the process. So debuggers have this concept of attaching and detaching from processes. I launched it from the process, the application, from the debugger, so it's already attached. But you can actually attach a debugger to any existing process, and it's quite interesting when you do that, because if the debugger has access to what you call the PDB, debug information or debug database, PDB stands for Program Debug Database, you can access all of this symbol information. So the program knows where breakpoints are, it knows what the names of the variables are, and whatnot. What I want to do is allow us to take a look at the code and set what's called a breakpoint. And if you've never set a breakpoint, this is going to be lots of fun. I'm going to set a breakpoint right here. And I do this by clicking right in the gutter. Bang, hit it instantly. I could have done that manually. I could have gone up to debug, gone to new breakpoint and set it this way. But really, when in Visual Studio, the easiest way is just to go into this gray area here on the left-hand side called the gutter, left click. It puts a little red dot, and that's called a breakpoint. And as soon as the function execution comes by and hits that line of code, we hit the breakpoint. And that's what it did. This function is called on-frame update. It's called very, very often. It's called roughly about, depending on the frame rate we're getting, it could be called anywhere from 20 to 100 times a second. So as I'm navigating, the screen is constantly updating, and it's constantly redrawing, and that's called every frame. So we have this callback called on-frame update. The plugin that we wrote has basically 3 entry points. Well, there's 4, but I just omitted the 4th one. There's 4 entry points that the application calls into. He initializes me, says, hi, I'm the application. I am loading you as a plugin, and here's an API so that you can control the main application. That's what Vim API stands for. It says, I represent the application. So you store that data aside so that you can use it later. The other time the application can call you is when you open a file. It says, oh, the application says, hi, plugin, I've got a new file that I'm opening just for your information in case you want to do some special handling of that file. Maybe you want to load it in another context, or you want to write the name somewhere or whatnot. You would put that code here. The rest of the code that you're going to write, especially in an application that does a lot of visualization like ours, you're going to want to make a logic that's called every time there's an update. And you have to be careful that this code is quite, it's efficient. And it also you have to realize that it's executing on one thread and you have to execute code on a second thread. Without worrying about the details of that and threads and whatnot, because I have a special kind of incantation you do here, in which says basically this code is going to execute in the correct thread. Let's follow it. I'm going to go into this function. I'm going to set another breakpoint, and we're going to see how this code works. So I'm going to press continue. Oh, and we've hit update controls from camera. What that says is that my code here, this is code I wrote for the purpose of the plugin, says, okay, well, the camera's moved. I want to update all of my controls, those little, sliders, those numerical boxes with the spinners, with the new values that are retrieved from the API. So what happens, I steps in and goes, oh, I asked the viewport, what's your camera? And then I asked the camera, what's your position? Oh, all right, and position is, look at this, it's a vector 3, minus 27, position minus 161 and 304. So this is the data about where the camera is in space. So as I move the camera, which represents you, or the avatar, the person looking around, you're controlling a camera, you get the position information. And then what I do is I set that information. So we've got a new position update, and we set that position to the control. So numeric up down is your spinner box. You've got a text box and 2 spinners, and that's something that Windows manages for us, but we can just give it new values. So what I do is I give it the new values, and then I ask the camera, what's your orientation? And that's like, well, where are you? Where are you looking? Are you looking up? You looking down, left, right? You rotate it like that, and that's called the orientation. Here I get to do some math, which is always fun, and that tripped me up for a good hour. I tried to remember how to convert from quaternions into Euler angles. Okay, really, really briefly. A quaternion represents rotation. You don't need to know how it works. It's a complex mathematical structure that represents rotation accurately. Typically, humans, we like to think of rotation as maybe something simpler like, oh, am I rotated around the x-axis? Am I rotated around the y-axis? And am I rotated around the z-axis? Okay, sometimes called yaw, pitch, roll, or Euler angles, or Euler angles, depending on your accent. So these Euler angles are very easy for people. You just say, oh, there's a rotation around x, rotation around y, rotation around z. Okay, good. So what I do is I have a function that's already written that does the conversion for me. Okay, so that's in the SDK. That's provided out of the box. You don't have to worry about it. Yay. What's kind of interesting is, how did I find that function to Euler or to Euler angles? Let's go in the watch. I'm going to show you something fun. So I've got a quaternion. Quaternion is here. He's got a value. Then you can say, well, what's the value? And it says, oh, it's got an X, Y, Z, W component. And they don't mean what you think they mean. They mean something special. Okay. And then the other question is, well, what are the functions that I have in my Euler angle? And guess what? I got a list of them. It's got set functions. It's got a length. The length squared is identity. It's even got a toString, which is kind of cool. That's what's toString. Now, looks the same. It just put quotation marks around everything. What I'm doing right now is I'm playing in the watch window. Watch is a debug tool which allows me to look at any value or any expression and execute it dynamically. This is something that C# can do that you can't do in C++ easily, which is just dynamically write new code and then just have it execute for you. And you can do that in the watch windows. All right, so I'm doing that. Coming back to the math, I didn't want to go too much into the math, but what you need to know, Euler angles are easier to work with. But they're in 3D math, you almost exclusively work with radians. Computers are really good at math on radians. They're not good at degrees, which most humans I know are better at thinking about degrees, 0 to 360. So you have to do this conversion, which is a multiplication. You look this up on Stack Overflow, tells you what that value is, you do the conversion, and then we set the controls. Okay, the try finally basically said, if there was an error here, well, I still want to make sure that don't update is set to false. Don't update allows us to prevent saying, hey, you know what? I'm updating the controls from the camera, but if I change the controls, I don't want them to send an event that tells me to update the things, because when I change the control manually, I don't want it to, I want it to update the camera, but I don't want to have updating the camera cause the controls to change. You can end up in this kind of infinite loop of the control change would change the camera, which change the control, would change the camera. And so you have a little Boolean value here that I set in the class. All right. All of this to say that we didn't write very much code. We have the code for the form, which is our window. We had the code for the plugin, which you saw, which is quite straightforward. There's a couple of events that you have to handle. Most of the time, you're going to put in your code into here. Then the other part of the code that you've got to worry about is what we call the plugin, the form designer. I'll show you a form designer, because this is where a lot of the power of C# comes in. I can control various aspects of the forms, and I say, oh, I want to put him here. I want to make him whatever. It's like he's telling me stop debugging, Christopher. Fine, I'll stop debugging. I'm going to stop debugging. Shut down the whole process. Because the debugger was launched, the program, when I shut down the debugger, it shuts down everything, so the Vim program is no longer running. This is one of the reasons I love C#. I can do things like that. Ooh. I mean, there's a lot of tools for doing that in other languages too, but this allows me to prototype ideas and work with them really quickly. You have all of these controls I can add easily. You pull them down the toolbox, and I can change properties over here on the side. I can change the values, the initial values they start with. I can change their min values and max values. So let's start from scratch and build a new plugin for the tool that doesn't do much, but it will show you the process of, okay, I got nothing. I want to plug in, and I want to do something. So go in to my solution. I could have created a brand new solution, but I'm going to do it from here because it's easier for me. So I'm going to go add a new project. You can do it from like file new. You could just start from there as well. So new project. Next, I'm going to do it here because I want to make sure that it goes into my sandbox and doesn't offend any of my existing my coworkers. When I'm doing a plugin, I'm going to do it as a class library or just library. It's C# Windows library. Remember, I can do it .NET Standard, Razor, WPF, class library, Universal Windows. I'm going to do it as a .NET Framework class library. And this is the easiest thing I can do. Now I have to say, okay, what's the project name? And vim dot super simple plugin, I'll just call them simple dot plugin. Remember, I have to end in a dot plugin. This is so that the plugin loader of the desktop application can find it. I don't want him to look at old DLLs he can see and just have him load everything. So we give him a name. We've got the location. I'm not quite happy with the location, so I'm going to change it to source vim.sandbox. Christopher, all right, good. I can put it there. He'll put he'll put a folder inside of that folder called vim.simple.plugin, and my framework is done at 472. I'm good to go. Let's create it. All right. So here we are. We've got a plugin. He claims to be a plugin. He references a few basic libraries out of the gate. And if I tried to make him a Vim plugin, if I went to, I don't know, let's just pretend I'm naively, I decided not to read any code, read any docs, and I'm just going to try and copy stuff and see what happens. And it could be a good way for us to start. All right, let's try that. So in theory, this should work. But I see the red squiggles saying, what's going on? Type of namespace Vim plugin attribute cannot be found. Are you missing a unique using directive or an assembly reference? Oh, that's interesting. Let's right click. Let's just hover over it. It offers me some options. Generate a class. These are fun features of the Visual Studio. Generate class. I don't want to generate anything. Add reference to vim.desktop.api. I like that. But for me, that's possible only because it saw me in my solution. I had a project called vim.desktop.api, and it saw that I had it. This won't happen for you. What you're going to have to do is manually go into your references. Oops, sorry, I'm in the wrong sample. We're in now simple plugin. I have to go into references, and I'm going to have to add some references. What you need to do is you right-click. So I right-clicked on reference, and I chose add reference. I have assemblies. This is .NET built-in stuff that's registered in the cache. I've got projects that I wrote already. You don't care. We've shared projects. I don't have any COM. Just run away screaming from COM. we have browse. So browse is what you're going to want to do. So you're going to have to browse. And what you want to do is you want to go and find the Vim application and go into its library. Now, I've given you the path on the SDK documentation page. For me, remember that my application lives in a little different place than your guys, so I'm going to go directly where mine lives because I know where he lives. It's going to look the same to you. It's going to look like something like this. It's just that my path appears different than your path. And remember, I told you we have all of these Vim dot files that we can include. So what I'm going to do is choose all the Vim dots. I'm going to remove, no, that's exactly what I want. I want all of these, they're all component files or DLLs. I'll remove Vim.exe. I could have left it. And you know what? I'm going to leave it for fun because I'm going to show you how to hack things like really. So let's press add. Okay, so all of these are going to be added. Sounds good. We've added them. All right.
We're just a reminder, we're at 10 minutes to go on the scheduled time, but just to give you a heads up. So not that you have to cut off, just wanted you to let you know.
Okay, do we have the Q&A, is it after the 10-minute time or should we?
Yeah, it can be if you're wanting to stay on after that. I just wanted to just give you some insight. Sure.
Okay, thanks for the time hit. I'm going to need to go through this. I think we're going to have to take the Q&A offline. I'll be on Slack. I'm going to be quite dedicated to the hackathon this week and on Slack to answer your questions. And the great thing about that is you're going to get a lot of wonderful one-on-one time with me.
Yeah,
So
I don't mind staying on with you and helping on the Q&A. Just I didn't know what other folks have other commitments. That's the only
all right.
concern. We don't have another event after this right away.
Sounds perfect. So what we're going to do is we'll wrap it up at 2. I will stay on for Q&A, but I'm saying though afterwards throughout the week I'll be online to help you out because I don't expect that many people are going to be able to get everything done today, but I'll be on Slack to answer questions and help people through this process and improve on the docs as we go. All right. So for the references, we've got a Vim plugin. I'm going to add it. So now I see this option using Vim.desktop plugin. This tells me bring in the namespace. Okay, Vim plugin. This is called an attribute. An attribute special label or marker applied to certain functions or classes. This tells the plugin loader that this class here, this Hello World plugin, is actually, and I'm going to call him simple plugin to avoid me getting confused, is a plugin and that he needs to be instantiated. Without this, it won't run. I derive from a class called Vim plugin base class. He found it. It's in desktop.api. We're going to remove the form because in this example there are going to be no forms. So base.init. I'm going to do the simplest thing I could possibly do. This is right line. My simple plugin was loaded. When you call base like this, there's a base class and it tells you, okay, delegate this call to the base class and have it do what it wants. Debug's not there using system diagnostics. All right. What this will do is this will output a message to, I'm going to set this as the start project. We're going to dive into it, press F5. Build errors, all right. This is because of my solution setup. You won't have to do this part, but this step is just for me. I'm going to go in here, delete this. Delete it. You're going to see it not work. No. A project with an output type, you guarantee you're going to see this error because you're going to forget. So with this step, but you go to properties. Remember I told you the debugger? You go start external program, you browse to it. For me, it's there already. I remember what it is. Good. Debug it, run it, press F5. Off we go. The other thing we have to do though, this is very, very important, this is the final step, is to make sure that the output of the application, so build application, your output path. This is so that it can be found by the plugin loader of your application. Remember, user profile, Vim, desktop plugins. Okay, so this is where the application has to go. So this tells us that the class library that we've created, the plugin, will go there. The other thing I have to do, and this is also very important, is I'm going to select everything here, all of these references, and I see in my properties here, I could just select this, I go to properties, and I go into properties, this is copy local. Go into here and you set this to false. I've documented this for you folks, don't worry. Okay, so now we're going to build this one more time. Build it. And now I'm going to start new instance. Now we're going to see the program is now you see it's appeared here. If I did not select copy local, it would have put a whole lot of DLLs into this folder and would have made it a big mess. The application might still work, but it's really, really messy. And I suggest not doing that. I suggest doing what I just did, which is turn the copy local to false so that you can see it. So right now, the debugger's initializing. He's looking at all your memory. Oh, he hit the breakpoint that we had set earlier. I remove it, let him run. He's trying the hello world. He's hit at the other breakpoint we set. I removed it. It keeps going. Press F5. And there's our desktop. Now, the question is, did anything happen? My simple plugin was loaded. Well, there's a reason why this program is doing almost nothing. It's because this is really, really important. So I'm going to do this. I'm going to go into code. And what we should see is message was my simple wasn't executed this time. So we have an issue because the plugin wasn't loaded. I have to apologize. The rush for time. I don't have time to fix this one. So the question is the goal was that we would put the sample here. So we've hit the limit of time, so I don't unfortunately have time to hit why this particular example didn't work. What I'll do is I'm going to put online the source code for all of the other sample that we know works, and I'm going to fix this and put this online as well. So now that I'm wrapping up, I'd like to open up the floor for some questions.
We don't have much in the way, which means that you did a good job of explaining everything, Christopher. No doubt. One point that was made, I think, by your colleague Joel, was that sometimes he said wanted to let everyone on the call know that the performance when it's not attached to the debugger, that Zoom cuts the frame rate down quite a bit, and normally they can see more like 100 feet a second on that project. So anyway, just maybe if you want to develop on that point.
Oh yeah, for sure. So I mean, I wanted to encourage everyone to download the viewer, install it, and hold on a second. Sorry, my computer's jamming up on me. I want to encourage everyone to install the computer, install the Vim projects, and go take a look around and see exactly how large those projects are, and you'll be able to see how smooth it is. On any recent machine with you don't even need an expensive GPU. I'm running just a regular old NVIDIA GPU, and we're getting a very, very smooth frame rates. I think what we'll also do is put a couple more samples on, but we've wanted to make sure that we put on real world samples. We didn't want to put on anything small because it just doesn't do it justice. You know, showing the old Revit house, it's not really good for today's times. We wanted to show a real project.
Great. Well, nice job. And I think that was powerful with, bringing in that really large, that's one of the challenges I think a lot of us have going into this whole digitalization thing is really dealing with real world large projects. So great job, Christopher. Thank you for your presentation and all the knowledge you brought and shared with everybody. Thank you all for joining us today. Want to encourage you all to still register at hackaec.com for the actual event, which will kick off Friday. We'll have lightning rounds. For those of you from the AEC Hackathon community know that that's usually our launch. So with these hackathon itself workshops, there's also a lot of knowledge to be gained. It's actually, Damon and I were talking this morning, we've had an amazing response to these workshops so we're really excited about the number of people that are coming on. So share with your friends. We do have another one tomorrow. That one tomorrow is on the Autodesk Forge platform. That kicks off. Let me grab one of my 300 pages of notes here to make sure I give you the right information. Jaime Rosales Duque it's called Getting Started with Autodesk Forge. It kicks off tomorrow at 10 o'clock Eastern time. So you do need to sign up for those, though. Those workshops are free, and on our website you can find other ones as well that are coming up this week. So we got a really pretty strong knowledge that can be shared pre-actual AEC Hackathon. So anyway, with that, once again, one other announcement I just saw coming through here from Joel Pennington. They're going to be offering, Vim will be offering a prize for the best Vim mashup. So with them being one of our top tier sponsors, they're really getting in deeply engaged. So there's a good opportunity for you guys to get involved in other ways in this event coming up. So great.
For sure. I'll just mention, thank you very much. I'll just mention two things. There is a Vim support channel on the Slack that I'll be present on, but you can hit me up on direct message. And the other point is if you're looking for ideas for good combinations of technology, I can help out with that. I'm also a mentor. So as much as I'm attached to Vim, I've signed up to become a mentor for the hackathon, and my experience also involves 3ds Max, Unity, all things C#, but as well as C# interop. So I've done C++, JavaScript, and Python. So as a mentor, I'm a general software development mentor, and I'm more than happy to help you out and also to brainstorm with you. So please, I love hackathon. So for me, this is a bit of a vacation for me. So love to help you folks out.
Great. All right. Thank you all. Hopefully you'll see you many more times in the coming days. Have a great week.
Thanks a lot, Steve. Thanks, everyone. Appreciate it. Bye-bye.